On the notes, I wrote out the words. I did not do the drawing. So that's why we're in class today, because I want to do the drawing and simplify your life. So on elastic collision is when I have an example of object 1 is going to collide with object 2. They're going to have a collision. And after they collide, which is what my arrow is, object 1 is still separated from object 2. They collide, they bounce off, they, a bowling ball doesn't get stuck into the bowling pins. They collide and bounce off of each other. A tennis ball and a tennis racket, a baseball, bat, you and a tennis ball, somebody was to throw a tennis ball at you, it's not going to get stuck inside of you, it's going to bounce off of you. Okay, so many examples. Now, inelastic collision is when I start off with 2 objects and you end up with 1 object. Okay, you start off with 2 objects, you end up with 1. So object number 1 is going to have a collision with object number 2. But when they do collide, they stick together. And so look how I'm drawing it. I'm drawing it significantly, obviously you can tell it's bigger. There we go. So I have a yellow and a red that are going to collide, and they become yellow-red. All right? We have a big fish and a little fish, and the big fish eats the little fish. Now we have 2 fishes. Okay? We have bubble gum in your hair, and we throw bubble gum in your hair. Now you got bubble gum hair. We got 2 astronauts in outer space. They collide, hold on to each other, and now we got 2 astronauts. Explosion is actually the opposite of inelastic. You actually start off with 1 object that's bigger, or 1 object, and it explodes, and it ends up with separating. Okay? Now, inelastic and explosion, those 2 that are combined, I drew those circles bigger. Why did I draw them bigger? Due to the conservation of mass that you learned about in chemistry class. I cannot just say, poof, that mass is gone. The mass needs to be conserved. And I'm stressing that because that's where we mess up on our equation. Okay? The mass is conserved. So, before we go any further, if, for an example, I only have yellow and red, what if I was to have blue and green on this side? Then I would have to have blue and green on this side. If I was to have blue and green, yellow, red, I would have to have blue, green, yellow, red all into 1. And let's stop and think about explosion. Is it always just 2 things, for example? Look at this. The skateboarder was on the skateboard together. He rides, falls off, and now they're separate. Okay, that's 2. The bird has a fish in his mouth, drops it. Now there's a fish and a bird. Now, okay, that's 2. But I have a glass plate, and I drop it, and then it shatters into, 148 pieces. I've got to pick up every single piece and take every single piece into account. So please, even though I'm just doing 2 colors, know in your mind that it could be more. And knowing that means that you're going to have to add more to the equation, okay, in that case, if that's the case, okay? Let's keep going, and we're going to turn the page. I made a mistake. If you watched the video already, the 2 bumper cars, I actually wrote the word Inelastic, it should be elastic. So please make that change. I'm so sorry. I said it, but I wrote it incorrectly on the video. So somebody told me, and I need to tell everybody, I apologize. Turn the page again. Because now we're going to take our momentum equation to a whole new level. If I know that momentum is conserved or saved, I can find the momentum before or after the collision, or the velocity or the mass before or after. So let's go ahead and let's go back to this. Remember, this first equation here was elastic, and it had a yellow and a red. They collided and became a yellow and a red still. Nothing happened. They bounced off of each other. Now, when I look at this equation like that, this right here is my original equation. Here it is also right here. That's the original equation. Okay, not bad. No, not bad at all. I need to make my original equation always look like my drawing. So, let's look. If I have a yellow and a red before the collision, after the collision, I need to have a yellow and a red. I promise you this will make a little bit more sense in just a moment. We've got to go through this before it makes a little bit more sense. Okay? All right, I see it. Yellow, red, yellow, red. The equation, yellow, red, yellow, red. I see that matches. Good. Because, I mean, I'm a visual person. I've got to see it myself to understand it. Let's go to, was that really you? Inelastic collision. Now, inelastic collision is when I start off with two objects, yellow and red. They collide, and look, their circle is definitely bigger because hint, hint, the law of conservation of mass. And when they do collide, they join together as yellow-red. Now, again, I still have the same equation, but I need to make my equation modified to look like this. So to do that, let me start off with the left side. That side is easy. I have yellow and I have red before the collision. But after the collision, I need to make this and combine it into one yellow-red combined. So let's do that. Let's just cancel that out. Now look, I only have one. Yellow, red, collides into yellow-red. I'm missing something though. Remember, this ball right here, circle, is bigger because of the law of conservation of mass. So even though I did that, which is good, I needed to do that, I need to say, hold up. This, do you see how it's red, number 2, mass? I cannot just poof, let it be gone. I need to conserve it. So how do I do that? I bring it over here and I say plus M2. Plus M2. You can see that. So M1, I can see over here on the left is yellow, and M2 is red. And now I have yellow-red combined into one. Hopefully it's making sense. Now let's do it, but we're doing it the opposite, which is explosion. So I start off with one object, yellow-red, all together as one. It, quote unquote, explodes, it breaks apart, and it becomes yellow and red. Now I need to make my equation look like this. Well, in this case, I'm going to start off at the right side. That's easy. Yellow and red. It matches that. let's go ahead and go to the left side. This left side needs to be combined as one. I don't care what side I pick, I'm just gonna cancel one of them out. So I'm gonna go ahead and just gonna cancel. It does not matter which one you cancel. What matters is that you conserve the mass, and so M1 cannot just be poof, gone. It needs to be brought over here, and we need to add plus M1. And M1 was yellow, so I'm gonna color that part yellow. And M2 was red, so now I have yellow-red combined. Hopefully this makes sense, because now we're about to use this in actual equations. Oops, there we go. So there we go, that's what it looks like. Give it to me, Nevaeh.
It's 9:30 and I have class.
Oh, 9:30 already?
Oh, yeah.
God, I didn't even click. Thank you, Nevaeh, I'm so sorry. Yes.